Hi friends, I am Shravana and welcome back to my channel Sparkling Future. Before starting with today's video, I request all of you to subscribe to my channel and also please like, share, comment and hit the bell icon for the latest video notifications. Thank you. Friends, in the series of data structures and algorithms, today we will see how to perform the Prepend method on the doubly linked list. So, what is this prepend means? Adding an element at the beginning of the linked list. So now let's see this diagram. So this is the doubly linked list I am talking about. Now already it has 5 nodes 1, 2, 3, 4 and 5. I wanted to add one element called 11 at the beginning of this doubly linked list. Okay. Now how to perform that? So first of all, when we wanted to perform this, it usually takes 3 steps. So first what we have to do is, this is the new node. So new node, we have to assign that like we have to get the new node, and then we have to have new node dot next to head, right? And then head to prev to this one, means this is the current head, right? The previous of the head should point to this one, so that the two backward and forward pointers will be coming to pointing to this newly created node, and this head should be moving to this particular one and it should become the head. Correct? This is not the head anymore. So 3 steps. What are the 3 steps that we just performed? First, we have taken the new node and we assigned the new node dot next to the head. So this is the first one. This pointer is the first one. And then this head arrow going back to this previous node. Previous means we are adding this new node at the beginning of the list. And finally the third step is moving this pointer, and which is actually head pointer should point to this new node. Okay, now let's code this and see how this doubly linked list prepend method works. Okay, so now we have this talked about 3 steps, right? So let's code for that. So first one is what? First step is having this new node of next to the self dot head. So new node dot next equal to self dot head. That is the first step. Then what we have to do? This part, this we have to assign this previous pointer to the this newly created node, which means that is the self dot head is this current pointer. Now for that previous, correct, it is in the previously, not in the next, right? So dot prev equal to new node, we have to assign that to the new node. And finally the third step that we talked about is moving this header pointer to this newly created node. So for that what we will do is self dot head equal to new node. So these 3 steps are performed for prepending an element in the doubly linked list. Got it? Now let's code this in the online compiler. Python online compiler, and I'm just randomly picking up one compiler. And yesterday we have the code. So this same code I'm taking, where for the doubly linked list class we have seen how the append and pop works, right? So I'll remove that pop thing. So let me have this append method, and when I run this it will show this 1 to 5 elements. Now we wanted to code first, and we have to append 11 prepend at the starting of the list, means at the beginning of the doubly linked list. So now prepend, and we have to pass the data here, because we have to have the data of what node, the number 11 I showed you right in the picture. So that 11 is coming here, whatever we pass it here. Okay, now again in this case we always thinks about the corner cases, right? So now let's say it is none, let the list is empty. In that case what we will do is, if self dot head is none, if there is nothing means the list is empty, then what we have to do, we have to have this new node. So before that what we have to have the new node. How can you create the node? By calling the class and by passing this data. So this data is coming as the input to this prepend method. The same thing we are passing it here. So what it is happens is, there is a node class here if you see. So here this data will be substituted and it will create a node for us. Okay, so that is this new node concept. Now we have created the new node here, and if that list is empty, what we have to do, we have to assign both self.head and self.tail to this. We have to point those two things to this new node, right? So self.head equal to self.tail equal to new node. This way we can add a new node for a empty list. Okay, now let's say it has only one element or more than one element, it doesn't matter, because at the beginning of the list only we are going to add a new element, right? So we don't have to have that another corner case check of having only one element in this particular condition, like in this situation. So now in the else what we have written, like whatever code that we have written here, right, in the text pad, these three things, right? Let me add it here. So what are we doing? First we are assigning the new node dot next to the self dot head, and then we are assigning the previous to this new node, and finally we are pointing the self dot head to new node. Okay, now let's save this. We cannot save it in the online compiler, but anyway, now we have all these things, right? So now let me call dll dot prepend of 11, and when I run this, so we have to print list prepend only I've done, right? Then 11 we are creating the data, and then we are assigning this one new node dot next equal to this one, and then okay, I think I got it. We don't have to return it. So it is just adding it. Again we have to print the list to see. So this, if you see, this print list is before the prepend, not after the prepend. Okay, now let me print that. So now you can see this 11 is prepended. Okay, so it's because of this print list. You can see, right, before and after I have kept. So before it has only 5 elements, and then after the 11 is added at the beginning of this list, not at the end of this list. Okay, now this is how we can implement the prepend method. And coming to the time and space complexity, so here also we are just playing with the pointers, so nothing much has been happened, like just the next and previous and then self pointers we are just playing here. So the time complexity of the prepend is also order of 1, and similarly we've only created a new node, right? And we have created, but anyway for adding that also we don't have to do anything. See, already one element is there and you are just attaching it. You are not something creating space for any of the any of the other than pointers. You are not creating any space, right? So because of that, even the space complexity is order of 1 for this. Okay, hope this is useful for you friends. Thank you for watching the video. Please subscribe to my channel for more interesting learnings. Thank you.